Next, NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
For over 4 decades, Voyager 1 has been drifting deeper and deeper into the vastness of interstellar space, carrying with it the hopes of countless scientists and the imaginations of people around the world. Launched in 1977, it has long passed the boundaries of our solar system, becoming humanity's furthest and most enduring scout into the unknown. After traveling more than 15 billion miles from Earth, Voyager 1 has just made a discovery that has stunned the scientific community and redefined what we thought we knew about the outermost regions of space. Before we start, smash the like and subscribe buttons for more updates. The discovery came through data transmitted from Voyager 1's plasma wave system, an instrument designed to detect vibrations of plasma, the ionized gas that permeates space. For years, Voyager 1 has been traversing what is known as the interstellar medium, the region between star systems in our galaxy. Previous data confirmed its entry into this realm back in 2012 when it crossed the heliopause, the boundary where the sun's solar wind is overcome by the pressure of the interstellar medium. Since then, it has been reporting back intriguing data about this mysterious environment, but nothing prepared researchers for what they found in the most recent transmission. What Voyager 1 uncovered was a persistent, low-frequency hum, an omnipresent signal emanating from the interstellar medium. This was not a burst or anomaly. It was a continuous, measurable vibration, the cosmic equivalent of a faint background song playing in the silence of space. What made the discovery so remarkable wasn't just the presence of this hum, but the implication that the interstellar medium is far more dynamic and active than previously assumed. Before, the interstellar space was envisioned as a mostly calm, silent void punctuated by rare supernovae or the occasional cosmic ray. Voyager's latest findings contradict that notion entirely. The plasma hum that Voyager 1 detected comes from oscillations in the gas particles between stars. It suggests that there is a constant energy exchange happening in what was once thought to be near-empty space. This hum exists outside the regions affected by solar activity, meaning it isn't related to the sun's influence and is, in fact, a characteristic of deep space itself. The scale of this energy and its consistency over time hint at unknown mechanisms at work in the interstellar environment. What's particularly fascinating is how this discovery challenges our current models of space physics. The interstellar medium was assumed to be inert on large scales, save for occasional disruptions from explosive cosmic events. Voyager 1's data indicate that the medium is humming with life, not biological of course, but dynamic and interactive forces that ripple across the cosmos like waves on a vast invisible ocean. These findings are forcing astrophysicists to reconsider the way they understand matter and energy outside the heliosphere. Another implication of this continuous hum is its potential role in the behavior of cosmic rays and how they traverse through space. Cosmic rays, high-energy particles that originate outside the solar system, are influenced by the electromagnetic environment they travel through. A more active and vibrational interstellar medium could mean that these particles behave differently than previously calculated, affecting not only how we model their movement, but also how we understand their origin and impact on systems like Earth's atmosphere. The data also hints at a previously underappreciated level of connectivity between interstellar space and solar systems like our own. If the hum represents constant motion, then it implies a flowing, interactive environment rather than a stagnant one. This raises the possibility that events occurring far outside our solar system could ripple through this medium and eventually have detectable effects closer to home. It's as if Voyager 1 has tuned into a cosmic radio station that broadcasts the rhythms of the universe, and for the first time, we're learning to listen. What makes Voyager 1's discovery even more extraordinary is the context in which it was made. The spacecraft is over 47 years old, and its instruments were designed in the 1970s, long before many of today's scientific models and data processing tools existed. Despite this, it continues to push the boundaries of human knowledge with a toolkit that is, by modern standards, almost quaint. This is a testament to the ingenuity of its design and the foresight of the engineers who built it. They anticipated not only the rigors of space travel, but also the profound importance of listening to the faintest whispers from the farthest reaches of the cosmos. The persistence of the plasma hum across long stretches of space has further opened up new lines of questioning about the uniformity of interstellar space. If such a hum exists in the area Voyager 1 is currently passing through, does it exist everywhere in the galaxy? Are there regions where the frequency changes, becomes more erratic, or disappears altogether? This discovery could provide the first clues toward mapping the weather of interstellar space, the flows, eddies, and currents of particles and fields that shape the galactic environment. Moreover, the hum may help scientists identify and interpret other signals that could be buried within it. Similar to how background noise must be filtered in radio astronomy to detect faint transmissions, understanding this interstellar hum could help isolate transient events or perhaps even artificial signals from distant sources. By establishing a baseline sound of interstellar space, scientists can better distinguish anomalies that deviate from this standard. In this way, Voyager 1 is not just delivering information, it's providing a reference framework for future exploration. One of the more speculative but deeply intriguing consequences of this discovery relates to the potential influence this energy could have on space travel and long-duration missions. If interstellar space is more energetically charged than previously thought, it could affect the design of spacecraft propulsion, shielding, and communication systems. Future missions venturing beyond the heliosphere will need to account for these environmental factors, adapting to an arena that is far less passive than earlier assumptions indicated. Voyager 1 is effectively charting a new kind of terrain, not one of land and rock, but of waves and frequencies. The subtlety of the plasma hum also reflects the delicate balance of forces in interstellar space. It's not a chaotic roar, but a quiet, enduring signal that suggests stability amid motion. This paradoxical state of persistent, gentle activity challenges many binary notions of space as either completely void or explosively active. Instead, Voyager's data paints a picture of a living medium, constantly shifting yet inherently balanced, much like the flow of tides in a vast ocean under distant celestial currents. What stands out most is that this discovery comes at a time when Voyager 1's power supply is dwindling and its systems are growing more fragile by the year. The fact that it could still make such a groundbreaking observation is both poetic and awe-inspiring. It adds a sense of urgency to the remaining operational time the spacecraft has left. Every new signal it sends could be the last, and yet it may still hold more revelations that redefine our cosmic perspective. The spacecraft has once again proven that even as it nears the end of its functional life, its value as a scientific instrument remains immeasurable. Voyager 1's ability to detect such subtle signals from so far away is a reminder of how sensitive and attuned our instruments can be when given the chance to observe the universe without interference. Unlike Earth-based observatories, which must contend with atmospheric distortion and electromagnetic noise, Voyager is free of such distractions, drifting in the pristine vacuum of deep space. This gives its readings a purity and clarity that is difficult to replicate, making its data a goldmine for researchers trying to unravel the mysteries of the cosmos. Another layer of fascination comes from the fact that Voyager 1 is entirely alone. No other human-made object is so far from Earth, and none are likely to overtake it for many decades. It is a solitary emissary, whispering back secrets from realms we cannot yet reach. This isolation enhances the weight of its discovery. It is not part of a fleet or backed by a support network of satellites. Its findings are singular, precious, and irreplaceable. The scientific ramifications of this discovery are likely to unfold over decades. It opens up a new dimension to how we conceptualize the interstellar medium, not as a background feature of the cosmos, but as a dynamic environment with its own behaviors and rhythms. It will inspire new theoretical models, stimulate the development of next-generation instruments, and perhaps even motivate future missions aimed at following in Voyager 1's path. The spacecraft has not merely extended our reach, it has illuminated a hidden facet of the universe that was always there, waiting to be heard. The constant plasma hum also prompts deeper philosophical questions about the nature of the universe. If space itself carries a background song, what does that say about the fundamental structure of reality? Is this hum a product of matter alone, or is it a consequence of some deeper principle governing the interactions between particles across vast distances? These are the kinds of questions that spark entirely new fields of research and redefine the scope of human curiosity. In the grand scale of things, Voyager 1 is a tiny object drifting in an unimaginably large ocean. And yet from this speck of metal and wire, we have learned something profound. That the silence of space is not truly silent, that the void is not empty, and that even in the coldest, darkest reaches of the galaxy, there is motion, energy, and music. This discovery underscores a universal truth, that exploration always reveals the unexpected, and that the cosmos is not a finished story, but a living, evolving epic. Voyager 1's detection of the interstellar plasma hum is more than a scientific curiosity. It is a reminder of the power of patience, persistence, and vision. It proves that the universe still holds secrets within the quiet, and that even after decades of travel, there is still more to learn, more to uncover, and more to wonder about. The spacecraft continues to reach further, not just in distance, but in meaning, offering us a rare and fleeting glimpse into the true nature of the cosmic sea through which we all drift. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us. What are your thoughts on Voyager 1's discovery? What do you expect happened? We want to hear from you. Thank you for watching, and see you next time.